Welcome again. This is our second lesson on calculus, and today we are going to look at the equation of tangent to a curve and equation uh, equation of normal to a curve. And I just want to say that the equation of tangent and normal, they're simply straight lines. They're simply straight lines that have a relationship to a curve. Now I'm going to illustrate it here. Let us say we have just have a Cartesian plane here. And let's say we have a curve that goes like that. This is our curve. That is how a curve looks like. Now the tangent line to the curve is a line that touches the curve at a point. The tangent line to the curve is a line that touches the curve at a point. So I'm going to call it the tangent to the curve. That is the tangent line to the curve. Now the normal line is a line that is perpendicular to the tangent line, that divides, that cuts through the tangent line at a 90 degrees. So this is the normal. This is the normal. Now there's something that the curve and its tangent share. The curve and its tangent. The curve and its tangent share the gradient at a point. The gradient at a point. You see where they are meeting right here. They share the gradient. They share the gradient at that point. Now, if you're not familiar with how to differentiate, you're going to have to go back to the previous video where I was teaching people how to differentiate or how to get the derivative of a function, because we are going to need that now. Let us have our first example. I'm going to say that find the equation of the tangent. Find the equation of the tangent to the curve. Now this is the curve. Y is x cubed plus 2x plus 1 at 1, 5. So I'm going to need you to imagine, like, this is the equation of that curve, and what we want is, and you see this 1, 5. Let's say it is there, 1, 5. So at this point, the gradient of this curve is the same as the gradient of the line tangent to that curve, right? So if you can find the gradient of this curve, we are going to say that it is the same gradient that is the gradient for the tangent line to that curve at that point. Now, to find the gradient of a curve, you need to differentiate the equation of that curve. Actually, when you differentiate the equation of a curve, the result is called the gradient equation, right? The result is called the gradient equation. So let's differentiate this. I'm going to say dy dx, it is going to be 3x to the second plus 2, and that's it. If you're having a problem with where this is coming from, you need to check the first video where I was demonstrating on how to find the derivative of a function, or how to differentiate function. But basically, what we have done is we have dropped the power. You see this 3? We drop the power down there so that we have 3x, and then we subtract the power uh, uh, by 1. So we have 2, right? The same thing happens here. The power was 1, so we dropped there. It remained with 2, and then 1 minus 1. We have x to the power 0, and x to the power 0 is simply 1, so we do not have to write it there. So this one is what we are calling the gradient equation. This one is the gradient equation. Now you'll notice that the only unknown in the gradient equation is x, and our x at this point is 1. Remember, this is always x and that is always y. So x is 1. So we are going to say that 3 times 1 squared plus 2 is the gradient now, right? All you need to do is to put the value of x there and you get the gradient. Now, of course, this is 1 squared, that is 1, 3 times 1, that is 3, plus 2, the answer is 5. So this is the gradient. And as we said, before we forget, the gradient of that curve, that is the gradient of the curve, is just the same as the gradient of the tangent to the curve. Now, the tangent to the curve is touching the curve at this point. All right. So this gradient is shared by both the curves. This is the gradient of the curve, and it's also the gradient of this line. This line, we have 1 point for the line, and we have the gradient, which is 5. The gradient is 5. Now, when you have 1 point, when you have 1 point, and you have the gradient of a line, there's a method that we normally use to get the equation of the curve. To get the gradient of a curve, of a line, sorry, to get the gradient of a line, you always get change in x, change in y over change in x. Now, what you do, you introduce a point. Introduce a point. Introduce a point that you don't know. So you just say x, y. And then you have this point and you have the gradient. So let us put it here. The gradient is 5. Change in y is going to be, because this is x and this is y, so it's going to be y minus y, and then change in x is x minus x, right? So we are going to say y minus 5 over x minus 1. And of course you cross multiply. You cross multiply. So you'll find that on this side you have y minus 5, and then it's equal to 5 times x minus 1. No, this is over 1. So y minus 5 times 1, and then 5 times x minus 1. So that y minus 5 is equal to 5x minus 5, right? And I would like to leave my answer in the form y is mx plus c. So I'm going to say that I'm going to take the negative 5 to the other side, so that I have y is equal to 5x minus 5 plus 5, right? And therefore the final answer is going to be y is equal to 5x. This is the equation of the tangent to the curve. There, uh, there we have a equation of the tangent to the curve. Now, when two lines are uh, perpendicular, this a property that we just remind you. Let's say this is our curve. Our curve was there, and then this is our line. Our line is y is 5x, and then we are looking for the equation of this particular line that is perpendicular to the tangent to the curve. So when two lines are perpendicular, there's a relationship about their gradients. The product of their gradients is always -1. We know that they all share the point 1, 5. The curve, the tangent to the curve, the normal to the curve, they all share that point. They all share the point 1, 5. So to get uh, the gradient of the normal, I will need to multiply the gradient of the normal times the gradient of the tangent, which is 5, right? And the property says that they should be equal, their product should be equal to -1. So that m1 is going to be -1/5. This is the gradient of the normal. This is the gradient of the normal because the normal is perpendicular to the tangent. So having the gradient, we are going to just repeat the same thing that you've done with the tangent, because we have one point which is 1, 5, and then we have our imaginary point here, and then we have the gradient as -1, 5. So we are going to say change in y over change in x is equal to the gradient. Change in y over change in x is equal to the gradient. And so very first, we're going to say y minus 5 over x minus 1 is equal to -1/5. All right. And so let us cross multiply real fast. Just cross multiply real fast. So uh, y, we will cross multiply with that. So 5 into y minus 5 is equal to -1 into x minus 1. Therefore, we'll open the bracket 5y minus 25 is equal to -x plus 1. All right. Multiply -x times x, and then -1 times -1. I mean -1 times x, then -1 times -1, and a negative times a negative makes it positive. And I'm going to again leave my answer in the form y is mx plus c. So I'm going to only to only remain with y on the left hand side. So 5y is equal to, this one will go to the other side, -x plus 1 plus 25. So that is 5y is -x plus 26. Right, so we divide all through by 5, by 5, by 5, so that at the end of the day, we're going to have y being equal to -1/5x plus 26/5, and this is the normal to the curve. This is the normal to the curve, and of course here the gradient must always appear there. When you write your equation in the form y is mx plus c, this one must always be the gradient. I hope the video is helpful to you, and you can get the equation of the tangent and the normal to the curve. Make sure you subscribe for other solutions. Thank you.